Okay, good enough. Well, thanks, Catherine, for helping me get set up, and thanks, Dara, for helping Catherine help me get set up today. Um, I don't know if I haven't looked at the whole list. There might be some folks that took the packaging class last fall, so this might be the whole class in an hour or so capsule. But what I want to do today is talk about food packaging and really just give you a primer, almost like a PR time to understand what packaging is as you think about it in your food science and school and in your career. I currently work at Target. I've been there about 15 years. I have a master's from packaging engineering. I went to Michigan State a long time ago. I've got a lot of experience. I started out at General Mills in packaging engineering. I went to Kraft. I came back to Mills. I consulted a while, and I've been at Target. And I currently work in the space of leading a team of engineers that works on our own brands, like Good and Gather in the food space, Everspring in the cleaning space. These are probably brands, if you do shop at Target, that you see. We have interns actually develop those products. And then I lead our sustainability work across the enterprise for packaging. I'm really loving, developing the best package, understand that, like, how do we make it more sustainable, but you still need it to get products delivered in a safe and efficacious way. Really understanding the importance of packaging and food waste, creating strong partnerships and mentoring folks and having fun along the way. So today we'll talk about what packaging is, which obviously some of this you would know, but how to think about it in a new way, why it's important. And then if you have any questions, please just put them in the chat. And if I'm not taking paying enough attention while I'm speaking, just speak up and we can answer questions along the way. So it's super informal. And then we can also have questions at the end. So I pulled this out of a textbook that we use in our packaging class that we teach every other fall, because I think even though it's just the first sentence, I think in one of the first chapters, it's a great description of packaging. Packaging is best described as a coordinated system of preparing goods for transport, distribution, storage, retailing, and use. It is a complex, dynamic, scientific, artistic business function, meaning that it's very scientific when it comes to protecting food and shelf life and creating a food that's safe to eat. To the artistic side is when you're walking down the aisle to pick something up that you want it, the package draws you in to touch it and pick it up and then have a good chance you buy it. And so these packaging functions can range from technical in nature, where I have spent my career, to those that are much more marketing oriented. And you might know people that work in the graphic design space or the industrial design space where they design packaging. So basically it's a system for coordinating. It's a coordinated system of preparing goods. So you want to transport these goods, like from putting them into a package and then putting them to a box and then distributing them, usually by truck today, but somewhat rail is being used a little bit more than it was a while ago. Just storing them in a distribution center or in the back of a store, to selling them once they're on shelf. And how do you think about your merchandising strategy to actually having the guests use them? And I'm a bit remiss, I should put in here that there should be an end of life function, is when you're done with the package, how are you trying to avoid creating waste by either reusing it, composting it, or today, one of the most common end of life solutions is recycling. So when you think about this technical to artistic, from a utilitarian perspective, the package really contains, protects, preserves, and transports the product. So think about I have a can of carbonated water here. Really, this can is just making sure that the water is contained, it's protected, it's preserving it, and it's moving it to the consumer. And then when you open it, there's functionality that comes into play. So how you want to measure something out or dispense it or facilitate reclosure, or maybe a child could use it. You also have the package to make sure it's communicating and informing and displaying things like on the front of panel, what's important to have somebody want to pick it up and look at it. But especially in the food space, you look at the nutrition facts panel, a lot of information on the product. That's all communication. And then how does it look on shelf so you can promote it and motivate someone to pick it up and sell it? So you think about things like, what is it sitting next to on the shelf? What are the structures, the forms, and the colors that are used in those categories? And then if you think about it from now, we're just going to stay in that technical space for a minute. There's basically 3 simple levels. Sometimes people talk about these with different words, but the definition doesn't change. There's the packaging that touches the food, which has to comply to the FDA. So like a pouch of granola, a bottle of water, a can of soda, a carton of like macaroni, it's direct contact. If it was a carton of cereal, there'd be like incidental contact, or a cup of yogurt. Those are the packages that you have the most interaction between the product developer and a packaging engineer in a company, because you want to make sure that everything's working in service of the consumer getting what you want. Then you have the consumer packaging. This is actually what sits on the shelf. So in some cases, like a gallon of milk, the food contact packaging is the consumer level packaging, or retail level packaging, we call it at Target. But if you think of like a carton of granola bars, the wrapper around that, like say Golden or Nature Valley granola bar, is the food contact package. And then the carton is more the retail package or the consumer level. That's what the consumer thinks about when they think of granola bars. And then there's the distribution package. This is typically in food, a corrugated container or tray with shrink wrap. It's also called a shipping case, container, shipping unit, or just the brown corrugated box. This is the same material you all get when you order something from Amazon or Target or Walmart or anywhere else. It's that corrugated box. It's an amazing material. It moves a lot of product across the country, and it's put on a pallet, or they call the pallet a cube or unit load. So imagine like a General Mills, there could be a whole pallet of brown boxes, and in each brown box, they would contain like 12 or 24 boxes of Cheerios. So you kind of think inside out. So as an engineer, you think about, what do I need to protect the food? How do I need to continue to protect the food and make sure this looks good on shelf and communicates to the consumer what they need? And then how am I getting it to the shelf through the distribution system? So food waste is a critical challenge today. These numbers are getting old, because I've been doing this class for several, maybe 3 to 4 years now. So I think in order of magnitude, they're still accurate, but I don't have the latest. Up to 40% of food is going to waste before it reaches the consumer, which is a crime when you think about all the resources that have gone into getting that food to be ready to be consumed. In developed countries like the US, a significant portion is thrown away by consumers. This is driven by, maybe I went shopping and brought too much food and can't eat it, so I toss it or compost it, or I go to a restaurant and you just get a huge platter of food that you really aren't going to be able to eat. And that's considered like the way the restaurant wants to like show and impress to you how they show up, but then you're also wasting a lot of food. In developing countries, it's a lack of packaging and logistics. So in countries, they're growing the food, but they don't have the ability to get it out of the field, packaged, and then delivered somewhere before it goes bad. So this is a huge amount of waste that we really need to continue to work on to reduce. And so if you look at that waste as to what does that really mean? So if you just look at this page on the left side, 40% of the food in the US is wasted. That means 25% of the water used, 25% of the US water use was used to grow that 40%. So a quarter of the US water use has gone to that food that is now being thrown out. It takes a third of the fertilizer in the country, a third of the cropland, and then it ends up filling 20% of a landfill. There's a social waste to this, that this wasted food could feed 25 million people. A huge financial waste when you think of all these things I just talked about, $165 billion. And then environmentally, the fact that you're putting this food into the landfill and it's emitting gases, you're increasing the temperature with greenhouse gases. So when you think of this, the 40% sounds like one thing. When you look at it with this multifaceted way, it really makes you pause and understand, how do we do a better job? Packaging is one key piece of this. There's a lot of other things like educating consumers on how to use product that doesn't look perfect, or how to read their shelf life dates, et cetera. But it's a huge drain in a space where we're not able to feed enough people today. So now I'm going to transition and just kind of tell you a story about all the players in packaging. We'll start out with raw material suppliers and converters. These are the people that make the packaging materials and make into the cartons or bottles or rolls of film that you make into pouches. And then we'll go into the manufacturers and the brand owners like a General Mills or a Target that use these materials to package their own products. And then we'll talk about what retailers think about with packaging, how consumers think about packaging, and then when the package is done its job, what are the end of life options? And then I'll go into some trends and current events sort of update. So when you think of packaging, all packaging for anything, if you're buying a t-shirt, a bottle of water, a new bed, it comes from plastic, glass, paper, aluminum, and steel. So really it's plastic, glass, paper, and metal. All plastics typically have been oil-based, coming from oil, and typical plastics that we'll talk about are polyethylene, polypropylene, polyester. But now there's a big, shift to looking at bio-based materials that could be those same plastics, but they're made from biosources that are renewable, or they're new types of plastic. Glass is a pretty steady state material. You basically, we'll talk about that, but you take sand and silica and just heat it up to the point that it actually turns liquid. Paper packaging is all over when you think about cartons and pouches that might have a paper layer. And then aluminum and steel, you tend to see aluminum where you can have it thinner because of the carbonation inside a bottle or carton, or sorry, a can can maintain its structural integrity, but a can of soup or something would be a steel can. So we'll get into some deep dives here, but just remember, if you ladder up, these are the only materials really that packaging are made of today. So we can talk about cans to start. The positives with cans are that they are trusted by consumers. They've been around forever. They have a long shelf life. Usually this product can last up to 18 to 24 months. You typically are moving the product hopefully through your grocery stores faster than that, but it has an incredible long shelf life. High process speeds by retorting. So you'll put like a bunch of ingredients in there like soup, and then that whole can will go through a retort process, which are to just really drive all the microbes out of it. And then because it's already sealed into the can, it's really a great vessel that has that long shelf life. There's quality perceptions have changed over time. Maybe 50 years ago, everyone thought a canned good was great, high quality, dependable, reliable. Today, as people explore more frozen foods or fresh foods, and they're not shopping the middle of a grocery store, they're kind of going around the edges. The can has like an overly processed point of view and might not have the same texture or flavor that you could get with a frozen product or fresh. And then when they produce cans, they call it bright stock. So they'll make a bunch of cans, but they won't label those cans until someone needs to pull them, because it's much more flexible to have a can, say for canned vegetables that might come to Target for our Good and Gather brand, or go to Del Monte for their brand, or go to General Mills for Cascadian Farms. They put the labels on when those orders are made, so they have that flexibility. And so those you'll see if you went to a can factory, they call that bright stock, because you just see a lot of pallets of bright silver unlabeled cans. And basically there's steel and aluminum. On the steel side, those ridges that you see along the wall, those are to give it structural integrity. So that's a conscious decision to actually create more strength by putting those ridges in there to have the can handle, vertical and horizontal pressures. And all the cans that you have a beverage out of are aluminum. So the pros, you have this great heat sterilization, which allows for that long shelf life, can able to withstand any kind of pressure. It's an absolute barrier. It is the only package that's really the absolute barrier. Gases can't come in or out, light can't get in, flavors can't come in or out, and you can't get any kind of infestation with any kind of an insect or something. And it's a cost-effective package because they've been around forever, and there's usually a predetermined select sizes of cans. You wouldn't see someone come out with a new can size, but they've just done amazing work to keep these things efficient. Cons are it's not easy to change those sizes, and they can get dented. And if you see it, you probably all have seen this, a dented on the shelf. People just reach around it, buy that because they expect the product could be damaged. So now we're going to move on to glass. This is inert. There's no interaction between food and glass. It's almost as impervious as metal, except you can have the light comes in, and then you can color it. A flint glass is clear. Amber, like used for beer, and sometimes some food items, is brown. Emerald, used like for wine. Lemon and lime. Olive oil, they use. I can't remember what we put into that, but it's a color that you make. It's called emerald, and you add color when you're making the glass. And it has good clarity for product images. Can be heat sterilized. It's a trusted package. Does not change volume or shape under pressure because it can handle high temperatures. And again, it's an absolute very except for the light. And it does also provide an upscale image. I think it's always been around, and I think today with a lot of the anti-plastic sentiment people are feeling when they buy food and bring it into their house, Some people are actually wanting to move back to glass, and you might see some products do that. So most glass used for food packaging is soda lime, and it's basically soda ash and limestone are added to get the desired properties added to the sand. Lead is used to give you crystal glass. This is very extreme, like a really nice wine glass where if you've actually, it touches something, you can hear that ring. That is not used for food and that's not recyclable. So there are different types of glass. And so basically it's about 70% sand, about 10% limestone, and about 15% soda ash, and then you add aluminum oxide and then the different clarifiers. But you're basically taking these ingredients, which are all dry and granular, and you're heating it to an incredible temperature, and the glass actually becomes liquid, and that you form your bottles by it actually flowing into a mold. Typically, a glass plant will run 24 hours, 7 days a week. They're very hard to start up, so they try to keep them moving. By the time you get those furnaces going, it's just best to keep them going. And so as we recycle glass today, they call it cullet. So if I was a glass manufacturer, I can take recycled glass. I say one of you put it in your recycle bin, it came through the process and it came back to my glass plant. I can take, I think up to 30% of recycled glass can be added for most glass applications. And the great thing about this is you're actually reusing it again, so you're not having to go to landfill, but it reduces the energy required to fuse the raw material. So when you don't have to, you're not burning, you're not creating the heat to cook the sand and all the other dry ingredients, you're really melting the glass, so it's more efficient. So the more cullet someone can add to their plant, the helps with the temperature not having to be so high. And it's very recyclable. Most people think it's easily recyclable. In today's market, there are some headwinds in the recycling space when it comes to glass because the end markets, people aren't paying as much for it. So it's actually having some challenging times. And when it does break in your bin, other materials like paper, plastic, and metal, they don't want the broken glass in there. So there's a little bit of market dynamics at play right now that make this a little bit of a challenge to recycle. But it is recyclable here in Minnesota. So now I'm going to switch to plastics. And plastics are the most common material that you'll see in food packaging. Like if we were talking wine, I would say obviously it would be glass, but in food, the science of the polymers and the different polymers that are in play really help people design exactly what they need for their food product. And so plastics are polymers, there's bags, there's pouches, like a bag of frozen vegetables, a pouch of like dried strawberry slices, a tray that you might have some meat in, a bottle of water, a plastic jar of peanut butter, the closure liner. When you open up a jar, you'll see something inside plastic or metal lid that's in the lid after you take it off the jar. And that's usually got a little bit of give to it so that when you put the cap on correctly and really tighten it down, that gives kind of a cushion to ensure you have a good seal. Plastics are used to line metal cans. They're also used for lining cartons like frozen foods, and they are used as an adhesive. So they have a huge role in food, and they're kind of, if I thought of all the materials, you can think of plastics as the workhorse for food. And so that when you get to the films, and when I say films, I'm talking like flexible pouches, there's really this incredible way to engineer just what you need. So if you were using a can or a bottle, you get kind of what can come off their production line, like a certain size can with a certain thickness of metal. And a bottle typically would have a certain weight to it and wall thickness. When you're in this flexible packaging space, you really like go back and decide what you need and then you build it. You don't take something from a packaging supplier like a metal can or a bottle. And you really need to first define your requirements. Like what are the barrier needs? What do I want to keep in this pouch and not let out? And what do I want to keep out and not let in? So like in meat, we have modified atmosphere or controlled atmosphere packaging where you flush the tray to get the oxygen out, and you might put nitrogen in there, and even carbon monoxide is used in that space. And once you seal that, you don't want those gases to come out because you want to have the gases in there to be around that meat for the shelf life. But like in seafood, you actually want a lot of oxygen transfer to keep it from doing some bad things. So you have to have a very high oxygen transmission rate in seafood packaging, which tends to be very, very tiny little holes that don't actually result in the product leaking, but they're actually letting the oxygen run through. So there's a whole, we could talk about barrier needs for a long time. And then product integrity, you need to think about, like, I don't want this to be broken. Like on potato chips, you'll see a lot of times a potato chip bag has air in it. And if you like laid it down and pressed on it, the air would be the first thing that would give you resistance, protecting the chips inside. And then you open the bag and you see the bag's not 100% full. That's a conscious decision to understand, how do you keep those chips from being broken while the bags are being handled. Or if you had frozen broccoli, you want to make sure that the frozen spears of broccoli aren't puncturing the pouch, and the material has to be strong enough. And then you have all your consumer needs, like you obviously want something to be easy to open. If it's multiple use, how do you make sure that it could have a reclose feature? And then you think about the equipment you're going to run on. And there, you can get into each one of these and go deeper, but as you kind of start this, a lot of these things come into play to help you kind of set you in a direction to go to figure out your final package. So then you think, okay, I'm going to make this package. There's basically 3 levers to play with to do that. You pick all your materials, and you can pick multiple materials and kind of glue them together. We'll talk about that in a little bit. And then how you form it, a rigid package or a flexible package. And then even within rigid, like a rigid yogurt tub or a flexible pouch of granola, there's different ways you form those plastics that can orient the molecules to give you different characteristics. And then you can add additives to even enhance the performance. Excuse me. So when you think about flexible packaging, there's basically 2 ways to do this. One is you cast it, like think of a horizontal line where it's, I'll show you this in a couple seconds, where you're melting plastic and it's just being pulled through like a piece of paper being pulled through horizontally. Or you can blow the film in a vertical way that orients the molecules. And then you can co-extrude either one of these. You can actually cast multiple layers of plastic to get to a desired end product, or you can actually blow them. And so here's an extrusion example. So that we're looking at this, say we're standing next to this machine. This green hopper is actually got little pellets of plastic that someone has bought and puts in there. It goes through this screw, and the screw is moving and creating friction. And that friction creates heat, and that heat melts the plastic through this entire barrel. So you can see it's going to get soft with the yellow, and then with the pink, it's going to get really soft. And then in the kind of reddish orange, it's going to be liquid. And at the very right, you can see it coming out as a thin layer. So think of this as a horizontal die. We're looking at it like as a cross section. But if we were looking on top of it, that might be like 30, 40, 50, 60 inches wide. And you're actually just melting plastic, putting it through this small die, and you're creating a sheet. And when you do blown film, so this is a whole different way to do this, you still have these hoppers. So this one, you can see there's 3 layers of film. You have the 3 hoppers at the bottom there. One says outer layer extruder, one says inner layer, and one says middle. So here, those 3 little hoppers would have different plastics in them, and they would come into this screw, and the magic kind of happens at the base there, where they're all getting melted because they're still going through that screw and friction experience. And then they're coming up almost as like 3 bubbles within each other. And then the air is blown from the bottom to blow this bubble up. And so this could be like a 2-story building. These are quite impressive to see. And then it gets blown up and it gets pulled away. And then it gets pulled off now like as a flexible layer. But now you've got it, there's basically 2 layers of it because the bubble's been collapsed. So you're just thinking of like if you had a balloon and you collapse it, you'd have 2 sides of a balloon. And it goes through a bunch of rollers to meter it, and then it gets slit and then rolled. And so at the very bottom on the right, the winder, that might be a whole roll of, say, cereal film. So you start with that plastic resin at the bottom. That die and extruder does all the magic work so that when that bubble is blown and going vertically upward, those 3 layers are actually consisting in that, that bubble. And here's a better, this is another picture to show that. So this is basically just looking at that side, a side view. So the green resin would be your outside resin. The tie layer could just be a layer to keep the plastics glued together, or it could actually give you some more barrier. And then the inside layer is your inside plastic. Typically, when you have 3 layers, the outside layer is there for structure, like on a pouch of dried fruit, to give the pouch rigidity and some form. The tie layer can just be basically a glue layer, or it could actually add some more barrier if needed. And then that orange one, most of the time in food, is polyethylene because it allows you to seal it when you're making a finished pouch. So think of the outside layer is structure, the middle layer is barrier or tie layer, and then the inside layer is your layer of sealant that actually can then heat on the production line where you're putting like the fruit into some pouches. And here's a picture of that bubble actually coming up. So it's basically a huge balloon. And like I said, it can be 2 stories. And this is, again, is a pretty tricky thing to get started. So when you do this kind of work, it tends to run 24 hours a day, 7 days a week, or at least 6 days a week, because getting this up and running is tricky. Just getting the bubble running and like working is the first step. And then you have to just even out to make sure the thickness between all parts of this bubble, and you're pulling it up and it's being melted all in the same way to get a consistent thickness without any like little pieces or gels of plastic that didn't melt, which can cause trouble later on. So another way to make plastics is called film lamination. So we talked about co-extruding or extruding plastics or blowing the films, and you can get all sorts of those combinations. Another way is to simply just take different materials you've already produced, like you've made a roll of paper or you've made a roll of film with a blown line like we just talked about, or you have foil, and you're just gluing them together to make a pouch. And these can be printed. So when you see anything that's printed, you have to assume it's a lamination, because when you see those bubbles of that film, that's like a saltine cracker wrapper or a cereal bag or any kind of like cracker that you, like a wheat thin or a Triscuit. That typically is that bag inside is a blown film, because it never needs to be printed because it's in a carton. But when you think of like that pouch of the dried fruit or frozen vegetables or things like that, those have to be laminated because you need a point in that process to actually print the outside layer that communicates to the consumer. And so a lamination basically brings things together. Like I said in it, we just glue them with different materials. So in this one, you might have that first substrate might be paper, and then the purple is the laminate. That tends to be a lot of times polyethylene, again, because it has a low melting point and it's quite adaptable with different plastics. And then the second substrate tends to be the sealant layer, which could be another layer of polyethylene. But you're basically just taking 2 materials and gluing them together. That first substrate most likely is printed. And so then you get your final structure with all the barrier needs, and then you have your printed package. And then these are basically sold in rolls to a company that's putting like the dried fruit into the pouch, so that they use the rolls, put on their machines, fill them, make those pouches, and then put them in a shipping cell. So when you get into film terms, it's very, very inconsistent in the packaging space. And I have a friend at Target that she's trying to pull some data together, and she finds it super frustrating because it just different things. We talk in metric, we talk in inches, we even talk in pounds as an indication of thickness. And it's nothing I can really justify other than to say, you just have to kind of get familiar with this and make sure you're working with packaging engineers to help you figure this out. But films can be in mils, they can be in this 48 gauge is just basically a metric or not metric in English system. And then if someone says we have 15 pounds of low density polyethylene in this material, you can assume that's about a mil. So super inconsistent. I wouldn't even worry about memorizing this. I would just make sure that when you get in this space in your careers, that you understand which one's being used and you can track with it. And so as you look at a packaging spec, you tend to go from outside to in when you write a spec. So this co-extrusion is 2.2 mils of high density polyethylene, low density polyethylene EVA co-extrusion. So that's basically it's all been made together, probably on one of those bubble lines that I showed you. It's 2.2 mils thick. And this is probably like something like a cereal bag liner that would be like a cereal in a box. And then when you get into laminations, this is almost becomes a work of art. You can have a total thickness of 2.5 mils, and it could be 48 gauge polyester, 7 pounds of white opaque poly. That might be there to help when you're printing the polyester, you have a white background to make the print look better. Then you have some metallized oriented polypropylene, and then you have 1.5 mils of this, again, low density polyethylene, EVA, probably a coax there just to make your sealant. And then other ways, if you have a paper package, like 26 pounds of machine grade paper, 15 pounds of PE, 000-285 foil, and then Surlyn is like a brand name of a sealant. So this area is like, I can't even give you tips here other than to just understand that you can understand what spec you read, but there's no quick way about it. And you can leverage your packaging engineers that you'll work with in your careers, or packaging suppliers that you work with, just to help to walk through these. But it's always outside to in when you write a specification or write a material data safety sheet or describe your material. And the two most simple barriers that you want with food is water vapor transmission and oxygen transmission. So you want to make sure you're not losing water, or you don't want to gain water. So think about like a bag of brown sugar. You don't want to lose water when it gets super dry, but say a bag of potato chips, you don't want to gain water because you don't want them to get soggy. So it can go both ways. And we talked about the oxygen. Those definitions are industry standard. So if someone said your water vapor transmission rate was a 0.2 or a 1, it would be based on grams per 100 square inches in 24 hours at 100 degrees Fahrenheit and 90% relative humidity. So those are actually the conditions you would test barriers on a film to give it a quantified answer. And this is just a chart to put in here as a reference. There's a lot of different materials that we use on their own in food packaging, or we like put them together, and how come they can have alternative names, give you a good sense of what's good at water barrier and oxygen barrier, and then like where you might see them. So if you like polyethylene, it's a pretty good water barrier, but it's not very good at oxygen. So you really want to have a simple like knead, just don't let the cereal get soggy. You can add polyvinyl chloride, PVDC. That gives you a very much better barrier. And then polypropylene is good, like a water barrier, but not great for oxygen. So the more you need oxygen, the more you're going to see these curated developed materials that have more than one layer to them. And again, this is just to give you a point of like reference to understand. So now we first talked about the raw material suppliers. So like in plastic, that could be like a Dow Chemical, who's pulling oil out of the ground and making polyethylene resin, and then are selling it to a packaging converter like Amcor or PrintPack, or a company that you might have heard of, to make the actual packaging. And so they now have these rolls of printed packaging. They sell those to the manufacturers or the brand owners. So in the retail world, we have manufacturers that make products for us. We buy finished goods. We don't own our own facilities, as most retailers. Kroger in the Michigan, Ohio area, they actually do own some of their facilities, but in general, retailers are buying finished goods. But brand owners like General Mills or Kraft Foods, Heinz Kraft, or Kellogg, they actually own their own production plant. So they would look at these converters as being a supplier to them and buying that packaging material, negotiating that so they can package their products. So these are the folks that are really driving that design. So this is what I did when I was at General Mills and Kraft, is I would work with those raw material suppliers and those packaging suppliers to develop what I think we needed. And so as a packaging engineer within a CPG, and even my team at Target and my coworkers, you really have to understand what do you need this package to do? So you can think about what are the jobs to be done by the package, what are the things you want to protect from not happening, and what would make this package successful. And so you want to do this along product development. So as a lot of you might go into food product, encourage you very much to really find your packaging people. They could be packaging engineers on the teams you'll be working with, like in your internships, or they could be packaging suppliers, because you might not have a packaging engineer per se, but somebody that can help you understand these things and look how they think this through. It's really important that can you guys hear me? Because I just got an internet unstable. Am I still good? Can you see me?
You're still good. Yep.
Oh, good. Thank you. When you think about doing this together with product development, it's when you have the best opportunity because you're really doing things together and you're jointly figuring out kind of what you want your package and product to be. So you have to think, obviously, what are your safety and quality non-negotiables? Like you have to make sure this product doesn't go bad and it's going to be the right quality when the consumer wants to buy it. What are your consumer needs? Like what does the consumer want this package to do? What do they expect it to look like on shelf? What do they expect it to do once they take it home? What is the business strategy and cost? Like, is this a high end, like an example is we have Market Pantry flour, Market Pantry, trying to think of something else, like bread, like a loaf of bread, not in the bakery, but in the aisle. And so our business strategy there is a low cost brand, but a good product. And so we're not looking to add any bells and whistles to the package, and we want the cost to be in line with the cost that we're actually going to ask the consumer to pay, which is low. But on the other end of the spectrum, my team just introduced some incredible packaging under the Good and Gather signature line in Italian foods, and it's all imported pasta and sauce, vegetables and olives from Italy. And so we wanted to use the packaging to cue, this was really special. It's not our Good and Gather pasta, it's not our Market Pantry pasta, it's our Good and Gather signature. And the product tastes amazing. The graphics are amazing. And we wanted the structure to show up in an amazing way too. So in that project, the business strategy was we want to invest in the package so it brings this whole brand and product to life to the consumer on shelf. And if you guys are ever in Target and you're in that pasta aisle, look for Good and Gather signature. It's kind of got a black look to it and it's got some amazing products. And then you think operationally, like what equipment are we going to run this on? What kind of cost do we want to spend here? Like if we have to do a lot of changeovers or we're going to be really trying to reduce the money, are we going to put a new piece of equipment in? So these are all things you have to be aware of as you define your package. And then environmentally, you want to make sure all your materials are safe. They comply with the FDA code when it comes to any interaction with food. And at the end of its life, how can the package not become waste? And then one that you probably don't think about a lot, but when you start to get into some new spaces and you're designing your package, you want to have an intellectual property strategy. So at Target, we have several packages that engineers have patents on because they actually design the shape of the bottle, and we want to protect that for our own. So people like Coca-Cola or Head and Shoulders shampoo or say Heinz ketchup, these packages that you guys probably all know from a distance, you just see the shape and the color, they tend to have some kind of protection because that bottle and that shape is so important. Actually, you can go from a patent, which is what you could get right out of the gate, to actually applying for a trademark like a Coke bottle, because it's not so much you have a patent on that bottle and no one can duplicate it. You're protecting that shape with a trademark because it is so well recognized as a Coke bottle. So you take all this information, you talk to all these people, you talk to your plant people, your quality people, your marketing people, your other product development people, and then you really kind of create your project plan and say, like, here's the things I have to have this product do. So what are my critical success factors? Here's the direction it's sending me. And then here are the things I know and here are the things I don't know. So what do I have to do to identify, test, and specify? So you want to start out with your product needs. And basically, what are you trying to protect? Flavor, texture, appearance, piece size. You would work with your product developer to say, what are these key product attributes? And then you want to determine your mode of failure. And this is the question I ask most engineers I've ever worked with. If the packaging engineer can't articulate the product mode of failure, they really don't know what that package can do. So obviously in cheese, it's mold. So we had pouches that have a good oxygen barrier, and we're flushing those out with nitrogen so that you're reducing the amount of oxygen in the bag to keep it. So you think through, okay, this material has to be, keep oxygen out, and it has to run on a piece of equipment that's going to have some kind of flushing mechanism. And then we've talked about cereal. You really want to make sure your cereal is not going to pick up moisture. And then you talk through your desired product shelf life as to when the consumer picks it up in the store, to say something clear like best if used by. And then that can inform your packaging needs as well. So something that's fresher, you probably wouldn't have as much shelf life you need is more just containing the product like a bag of apples, but when you look at something like applesauce, there's a need to make sure the product is going to be served. Excuse me. And so you really just think through the characteristics of all the things that could happen that you want or not want to happen, and how does the package and the product formulation come into play. So you want it to be safe and not spoil. You want to maintain your flavor. You want to have good aroma. That's important. You want to maintain your texture. You want to understand if color is going to be infected, and you might need to keep some light away. Nutritive, basic aesthetics, like you don't want the product. You bought a bag of cookies. It could be that everything's edible, but your cookies are broken in the supply chain as they got delivered. You want to make sure you're developing packaging and handling procedures to avoid that. And then you don't want someone to have been in the package before you. So that's basically thinking of tamper evidence. And I can tell you a funny story. When I used to work at General Mills a long time ago, I worked on a cereal called Trix, which I'm not even sure any of you have heard of it, but it with these little balls of like orange, red, and yellow puff balls. And it was this like citrus cereal. And it was, you'd open it up and get this great lemony, citrusy smell every time you opened up a box of this cereal when you opened up that inside bag. And General Mills was looking to change their packaging equipment from one type of machine that was using this wax line glassine, this wax coated glassine paper, to a high density pouch, because the machines were going to run faster, we'd have better seals. We thought we could even maintain and extend our shelf life. But every time we did the shelf life testing with this Trix cereal and the new high density polyethylene material, we would get these awful aromas. Like we'd open up the bag and it would smell kind of this sickly, sweet, weird, almost chemical smell. And we realized that that wax coated glassine paper that we've been using forever was doing something amazing to keep that aroma. So that first time you opened up that box of Trix, you would get that great lemony smell. You wouldn't get it the second time, but that first time was kind of the thing to get. And we never had a very good test for this. So I think, I don't know how many shelf life tests I would run. We'd pack the cereal in these different materials. And then I would have to get this guy, his name was Jim Olson, and he would meet me down in the test lab. And he would literally be the one to smell these boxes as they come up, because we didn't have any kind of gas chromatography or any way to do this. It was all this very arbitrary, but very clear point of view that if it worked. And he would literally have to stand next to me, open them up and tell me, like, I mean, if they were super bad, I could tell, but he had these much more acute sense of what was right. And we went through many, many, many materials before we could figure out what we didn't even realize we had with that glassine. And so aroma can be tricky. Flavor can somewhat be tricky too. I think the rest of these, you really, like, it's a binary thing. Like, you don't want it to be crunchy, you don't want it to be broken, you don't want it to lose nutrition. But there's a little bit of art to some of this work. And then you want to think about anything with safety over time that you don't want to affect your product. You want to keep your quality, your aesthetics, and your adulteration. So I kind of talked about those already. And then when you think about shelf life, it's the time of manufacture until estimated use. So this is basically the time you're making a pouch of, say, dried cherries, and you're sealing it, and it's going through the supply chain, and you want to make sure it's going to be great when the consumer picks that up at the grocery store, takes it home, might put it in the cupboard for a while and open it up. Most center of store shelf life is 9 to 12 months. Where you have shorter shelf life, you will have like 90 days, could be things like potato chips that actually are just moving through the supply chain for faster, even though they are in the center of the store. When you get into the dairy area, I think I would say, like, you could have this like day life on up to 30, 40 days for yogurt, and then maybe 120 days on some other things like cheese. But usually you're a year, just kind of just taking a high level point of view. It's about a year within the store, with the exception of chips. And around the outside, it's like a few days to 3 to 4 months. And then you can think about, my shelf life be affected? Well, if you made the product and it got hot, be triggering some oxidation that the package can't do anything about. You just made a bad batch of product, and that can shorten your shelf life, or can actually make poor product right out of the gate. But if you process something at too high of a temperature, you actually are going to create something to happen that doesn't matter what package you use, the product's going to start to fail. And then you think about your distribution conditions, like, is it going to be in a, if refrigerated or frozen, and how many cycles of temperature change might that go through, how it's handled, that temperature and handling can affect your shelf life. Don't make a good leak in the, so you're not going to get your shelf life. And then your product consistency. So product, like I remember when I used to be at General Mills, like the smell of a toasted Cheerios was amazing. And you'd always want it, like we'd always, like after we'd work on a trial, we'd take a couple bags off and we wanted to test the seal or actually taste the product to make sure we're good. And that fresh taste is amazing. Just like that Trix aroma right off the line, it's amazing. Quality changes do happen over production. So you want to work closely with your product developer, because those are product characteristics that the product formulation have to address. In some cases, that might be a different processing parameter that you want to adjust, and the package really cannot address that. Like Cheerios are going to lose that incredible toasted flavor over time. Doesn't matter if you put it in a metal can, a glass jar, or a pouch. And then you need to think about what people do at home, right? That I might have bought that bag of dried cherries, but I could have then left them in the kitchen for a couple of months because I think of it as like something I want to keep on hand. So how does that come into play? And then once I've opened it, how do I want to make sure that we're giving the guests, the consumer, a sense of that this will last enough time? So like a pouch of cheese, once you open that, all of the brands now have these great zippers on them to close them. They'll keep that fresh for a week or two maybe, but that's not going to be as fresh if you had about a pouch of cheese in your fridge and you haven't opened it for the first time. That will last much longer. So things that can go wrong, these are just examples, but like a failed seal, like you could have a seal that, say you turn the line down because something jammed up on the line and you started running the line again. Well, your seal bars maybe didn't heat up as fast as you wanted and you're still making pouches. So they might have given you like a initial seal, like gotten tacky enough to stick, but you didn't get enough heat. So like through the supply chain, that seal might pop open. You can have holes in a pouch because the product's puncturing it, or the zipper. I'm sure you've all had this problem where you open up a pouch and by the time you rip it off, you rip the zipper off, or the zipper has gotten sealed so tightly that when you try to pull it apart, it stays on one side of a pouch. These are all things that happen in the production, and they're compliance issues, not design issues. And then you could have flavor change. You could have oxidation from the actual plastics that have been over-processed that could actually trigger oxidation in the product. I've worked on projects where they used a solvent in the printing to get some kind of cool printing effect, but that solvent then was going into the pouch and affecting the product and giving it a chemical flavor. And then environmental transfer. This is becoming actually more important now with all the online shipping that we do. Like you typically in a warehouse, you wouldn't put like your detergent and your fabric sheets, like Febreze fabric sheets or something that's scented, or bars of soap next to the food. In a warehouse, you would put all that in the right place so there was no aroma of like a cleaning item next to a food item. But as people are ordering things online, you are getting people getting a box of something that could have your Febreze sheets and maybe bars of soap that is supposed to smell like lemon, and you might have a bag of bread in there, and you can actually get that transfer. I know for Target, we do a lot of work to put extra bags around those products to prevent that. Again, you're creating more waste with the packaging, but it's like this online thing that's getting ahead of us in some ways. And so we're doing these hacks to get the products to the consumers in a good place without those kind of environmental transfers happening. And so one of the things you want to talk about, and I'm just going to touch on this to tell you this is a piece to go into. And when you get into your internships and your jobs, you'll see these in the production plan. So it'll show you kind of how all this comes together. But you can do fillers that can be done by weight or volume. So like a cake mix filler can tend to be by volume, right? It's very consistent powder, and it just fills the volume of a certain cup. And then that tends to be just the amount that you actually put the weight on the package, but your density is so consistent. You can use a volumetric filler, which could be faster. And then most things are weight, like potato chips or candy or those dried fruit. things we talked about, where they have many different kinds of fillers, combination fillers, so you can go quickly and be super accurate with your weight. And then you have dry versus liquid fillers, and they have viscous products like peanut butter, where you might have some sort of a piston involved to actually fill the package because the product just won't flow. And then you have the cappers that you put on there. You might have a machine to put like a membrane on the top of a peanut butter jar, then you screw the cap on. Or you could have that membrane would be sealed on. And then once it's sealed, you screw the cap on. Another way is that membrane material is actually in the cap and you screw that on, then it goes through an induction heat and it goes through like just a tunnel of heat. And in there, that membrane that was in the cap seals to the jar so that when you open it, it stays with the jar and then you take the cap off. And then you peel the membrane off and use the cap as you reclose it. There's labeling equipment. There's baggers and pouch machines. Like how do you put bags of something into another bag? Then how do you put something into a carton? And then there's a bunch of equipment to make sure you've had the right weight in there. You don't have any metal or x-ray. You're adding the code date. And then you basically have a case packer at the end of this whole line where you're putting in like 12 pouches or 12 cartons or 12 jars of peanut butter that are going into a corrugated box. And that's either taped or glued. And then that can be put on a pallet. And that can be done by a robot, where you actually see the robot has got in its program the pallet pattern, and it's actually picking up those brown boxes and putting on a pallet. And in some lines, you'll see accumulators. They basically are something you can insert in any piece of equipment, where if the upstream machine is running and the downstream machine goes down. So say you're filling pouches or bottles of water, and the labeler goes down, you don't really need to stop the filling because you have these big rotational tables that will just let the bottles keep being filled and capped, and they'll just collect. And then hopefully you get your labeler up running and then you can pull that inventory in. It just gives a little bit of a cushion on these production lines when you have so many interdependencies, so that those accumulators can be put in place strategically to say, we typically have a lot of like labeling go down, say in a water plant, but you don't want to stop filling. So they would insert that accumulator in between those two to give it sort of like a cushion or insurance. So when you think about regulatory compliance, this was beat into my head by one of my first bosses, so I keep beating it into everyone else's head when I do this class, is that the FDA does not approve packaging materials for food contact. It does not, you don't send your package to the FDA and say, can I use this for this product? There's regulations that they define, and it's the brand owner's responsibility to make sure they're publishing with those regulations. So at General Mills, we always wanted to make sure that all the materials complied to the FDA, not that they were approved by the FDA. And then we had our packaging suppliers conduct the testing. And so for the food area, it's the FDA 21, the CFR Code of Federal Regulations 176.17, food types and conditions of use. And basically what's in there is like, here are the different materials, and here are the excuse me, the requirements, like if it was wet or dry, or could go into a microwave, is it oily versus aqueous, etc. So this is, I've looked at this book a few times, but basically just to understand what the architecture of it is. So if you look at new materials, so if you ever are exploring something where you're bringing something new in, it should definitely feel different to you, because we don't do this very often in food, that you make sure that your packaging suppliers are doing this testing, and they provide a letter to say that it's proven the compliance. Okay, so now we're going to move to retailers. And now this gets more into the supply chain and more of the artistic part of packaging, because technically now you've delivered this great package and this great product to a store, and they want to sell it. And so as a retailer, we come in with a totally different point of view. We assume that you've got the right packaging material, you've got the right package fill, you've got it sealed right, and the product is fine. Now, how do we want to bring this to the consumer and have them want to buy it? So you think about consumer interest and expectations. Does it fit on the shelf? Sometimes you think that's a simple thing, but it can easily be overlooked if we change something and all of a sudden we realize it doesn't fit on the shelf. And for a retailer to change their shelf, it's a major effort, and you rarely ever do that. You want to make sure it's being rotated on the shelf. So there's first in and first out, or last in and first out. So you really want it to be first in and first out. So if I'm putting pouches of those dried cherries on the shelf, we really want our store team members to pull the back ones up and put the new pouches behind there so they're moving that inventory. But as people get busy and they got a lot to do during their shift, sometimes they just keep putting the new pouches of cherries in front of that. And then like a year later, you're realizing there's a pouch or two that are out of code date because they hadn't been rotated. And then we're always to make sure that the package material and the total cost is what we think it should be for our brand and our product, and it performs technically. And then as we get into things, I've italicized 3 here that I think over the last several years have become more important. Supply chains are changing. People are getting things delivered directly to their home. People are coming to Target and driving up to pick things up. People are coming to Target where someone has pulled it together. You go in and pick it up. So the whole package experience is getting different, and it's not staying in that corrugated box for as long as it was like 20 years ago. So that individual pouch or carton has some heavy lifting to do in the new supply chains. And you can imagine that, like when you order your food, even if it's by a shopper like Shipt who does shopping and drops it off at your house, that package is going to have a different experience than the way it was 10 or 15 years ago when it came into the store in a brown box. It sat on the shelf, someone picked it up and took it home. Basically driven by a lot of this online ordering and shipping. And then the end of life of packaging is becoming more important. And as engineers think about their materials, from technically protecting the product to having the guests want it, to make sure it's on the right cost and all the other things we talked about. And what can the guest consumer do with this at the end of life so that they aren't feeling guilty, and can they reuse it or recycle it or compost it? So this is a picture, and every time I see this, it kind of reminds me when I first came to Target. I kind of grew up at CPGs, consumer packaged good companies, and we would just make pallets of cheese and pallets of Cheerios and pallets of frosting and pallets of mayonnaise, and they would go out of truck, just a whole pallets and pallets of the same thing. But I never thought about anything after that. And then what happens, those would go to warehouses, to a retailer. And like a Walmart, they're 6 or 7 times bigger than Target. So they could take a whole truck of pallets of Cheerios or a whole truck of pallets of cheese. But people like Target were not quite that big. So we tend to take part of a pallet or a few cases that come into our warehouse. And so right away now, we don't really have a pallet that's helping protect the product. That brown box is kind of got to do all this work. That comes into one end of our warehouse, and it goes through either straight to go into a truck if it's going to move that quickly, or it goes into storage. And this is a picture of a truck leaving our warehouse going to a Target store. And this is where it gets super interesting, because now the store is only ordering what they need. And typically in a Target world, a truck would get delivered at night. If it's a super busy store, they might even get a couple trucks at night. But that store orders what they need. And you can see from this picture, they needed a lot of different things, not very many things of one. And so this experience of the package from a retail warehouse going to a store shows this kind of work of art / science to pack this up. And if they don't do this well, you get a lot of damage, because now your packaging is bearing weight that really no one expected it to do. And so I was just talking to someone on my team this morning, we were having some damage issues, and we started to think about the case, some kind of weight in this sort of a situation, because we know it can get through the pallet and it can stay in the storage okay. But as one single case, we think it's getting too much weight, and the caps are getting damaged. Most retailers have like guidelines, like they put the heaviest stuff on the bottom and there's a food zone in the truck, so you're not putting all this together. But there's still this sense of like every day it's a different kind of Tetris puzzle to figure out. So when you think about it, getting through all that and it's on the shelf, this is where the package becomes much more of an emotional, artistic design thing. So you think about the venue, like where am I shopping online, or am I standing in front of this chocolate and picking out a special chocolate bar? Okay, so what kind of a way, how can my package create some awareness? Like someone wants to buy a chocolate bar, but how do I get them to look at my chocolate bar? And then how do you communicate that to bring the consumer in? And then how do you evoke an emotion? So I'm going to pick that chocolate bar because I love the art on it or the name or something that just connects to me. And you did make this decision to touch it or not. And once you touch it, you have a much higher sense you're going to buy it. So this idea of someone reaching out to touch something is pretty important because there's a higher chance that that package would go into your shopping cart versus if you don't even reach out and touch it. Oh, sorry. And then fulfillment. Once you get home, like I bought this really beautiful chocolate bar, maybe I paid a little more for it, but did it taste good? Was it fresh? Like, would I buy it again? And so you have this whole kind of thing happening in nanoseconds in a consumer's mind. 20 years ago, it was mostly happening in the grocery store when you're staring at something like, think wine or chocolate or pizza or olive oil, where you know you want something, but you don't really know it's going to be a Hershey bar or a certain olive oil. This is where this package really, you want to connect with the consumer. And so that leads us to consumers, because now we want to make sure we're giving the consumer something that they want to buy so we can sell it. And everyone else behind us, the retailer, the manufacturers, and those packaging suppliers want the same thing. So there's some really interesting like tenets that go into this space. And I'll start out by saying it's a lot harder to test packaging than it is to test product. You can test product, and product can be like it's too crunchy or it's too green or it's too sour or it's not sweet enough. People are very able to articulate those reactions. When it comes to packaging, they tend to do things subconsciously so that you can't just have them look at a package and say, would this work or not? They're very good at pointing out when it doesn't work, but there's a more subconscious. So you have to design your packaging test to be a little more like experiential, and then you understand how things perform. But just before we even get into that, more than 60% of consumers will buy a product off the shelf without any prior knowledge. So that means that package is basically your whole entire marketing campaign. Consumers recognize shape and color first. So like a Coke bottle, a Hershey bar, a Tide bottle. You all know these different packages. You see that shape and that color. You know what it is before you even read anything. And packaging is, this is a quote from an old CEO of Coca-Cola, packaging is the single biggest driver of sales increases in the world. And you think Coca-Cola selling Coke all over the world, their package was their common thread to be their marketing campaign. There's a shift with this, with the move to online retailing. I think the essence of these things are still true. However, how people look at them, they might be looking at like a product information page online now versus stand in front of them. So how do we make sure our packaging is designed to look informative and appealing online as an image versus in the store? And so here are examples of shape and color. And I should have jumped to this, but these are probably all packages that you could see it. And if the name was blocked off, you would know what it is. And that's a huge, huge, they're in the camp for the technical and graphic design of these brands, where they've created such standing and awareness and familiarity that you don't think about what the words are because you know what they are. And here's an interesting package that someone sent this to me. I think it was 2 years ago when I was teaching the packaging class. And it's the question, is this a good package for cleaner or not? This is a bleach alternative cleaner that's very popular in Hispanic markets. And they were actually using these bottles for smaller sizes, and they were getting a lot of flack for this because those bottles were basically the same kind of bottles you could put a bottle of water in, or like a soda, like a 7-Up or a Sprite. And so here's an example where you probably shouldn't have done this, because you're now showing a shape of a package that's very typically something you would drink out of, and you have a product in there that you would not want to do that with. So there's some norms within these categories you always want to be mindful of. So when you test packaging, we talked about how this is hard. You have to kind of create this experience. And there's many types of testing. I'm just going to give you a high level overview here. But the first thing is, like, what is your goal? Are you doing some guidance up front to say, do you want this to be in a pouch or a carton or a jar, where you're doing it in development? So it's guiding your development decisions. You can go to, and you have a final package and you want to say, we know this is the right package, but we don't know if people are going to get it on shelf. So you actually go and do some shelf testing where you have it on the shelf, like in a select city or something. And then you can even keep doing that. We have real in-store real-time sales. We have it for sale for a while to predict sales. And this could be because you're debating to have a whole new production line put in. And one of the new products that General Mills has put out in the last 3 years is Oui Yogurt. And a good friend of mine and I were co-teaching the packaging class 3 years ago. And his daughter works at General Mills now as a packaging engineer. And they built an entire new line to handle glass and to seal those glass jars and to label them and move them into shippers, not like the little yogurt cups that you think of Yoplait that have that kind of inverted cone. So they probably did a ton of testing to make sure people were going to buy this thing before they put all that equipment, investment, and time into place, because it was a huge investment for them. And so we talked about this packaging is difficult to test. And there are some questions you just have to watch people do. Like they might give you an answer, but it's not it may not be the right answer because they're not able to articulate this. And one example I had when I was at Kraft years ago, we were looking at different reclose systems like the zipper that we all are in today, but there were some other ones that might have been fold over with clips. And I was talking to this one woman and she was holding this pouch of cheese. And I was asking her, do you want this pouch you want to feel that you close it, see that you close it, or hear that you close it? And the entire time she was rubbing her finger along the zipper, which told me she wanted to feel it. She wanted to make sure she had that zipper closed and like the tutting groove was connecting and she had closed it. But she goes, oh no, I want to see it. And I remember sitting there thinking, wow, like I shouldn't be asking you questions right now. I should just be watching you and I can deduct that you want this to feel close because that's what you're doing. And so there's this subconsciousness that you really need to be mindful of as you do your testing and put them more in a typical usage. So a lot of times you can send packages home and have them use them and then maybe take pictures versus ask these direct questions because you'll get better results. And then from a super high level, there's two types of testing. There's the qualitative testing, like you're doing small focus groups or sample sizes, maybe even like at Target, I pulled people in a room and just had like within 2 hours, 30 or 40 people come through and give me some guidance, people that work at Target but aren't into packaging, but they can help me understand like to move away from some idea or move toward one. You can go into their focus groups are like in this picture where you can have people sitting here talking and typically there's a one-way mirror and these people know this, but like we could be sitting in the back watching a moderator have these folks react to a package and you're just watching them and hearing them. So you learn some really rich information there. Those usually are moderated by someone that knows how to manage a different group like that. And then they can come back and talk to you and you can say, hey, can you ask these more questions and kind of pivot along the way. And then there's ethnography, which now with phones, it's super more common. It's like, instead of having to go into someone's home and like sit there with them and be kind of evasive, you only do a few of these, you can actually do that or just have them take pictures and say, take a picture of your fridge and show me how you're storing your condiments, or take a picture of where you put your dog food and tell me like what's working and what's not. And you get a real good dose of like, this is the real world. And you're sitting here developing packaging at a company. Sometimes you don't forget it, but you kind of do forget some of the basic things you don't want to forget because you're not like this close to the consumer. And then we talked about the quantitative testing, really to inform business decisions, much larger sample size, much more statistically significant and more money, but you're usually making bigger decisions from the results. And so this is something that I had heard years ago from P&G really coined these words, or maybe someone before, but I learned it from people that used to work at P&G, is that first moment of truth. Like when you see it in the store, what makes you want to pick it up and buy it? So if you pick it up and buy it, that's a successful first moment of truth. And then you have the second moment of truth at home, like I'm actually taking it home and using it, storing it, opening it, closing it, having someone else use it. And if that's successful, then you've hit both. If you have a great first moment of truth, but a very poor second moment of truth, you might have a high trial, like people will buy this, but there'll be no repeat. And these are two very common metrics when you look at sales, trial and repeat. High trial and low repeat means it didn't perform well at home, but it did perform in the store. And then low trial, but high repeat suggests you need to do something to get people's attention in the store, because once they buy it, it works really well and they like it. So those are great metrics to help you understand how you want to continue to evolve your design. And so you can think about different types of packaging. You can just test the graphics, right? Like you might just have a computer test where you're looking at different images on your own laptop at home and you're just reacting to things. There's equipment that you put these certain goggles or glasses on. It can track your eye and what they looked at first, to say like for a box of cereal, you tend to look at the middle first. For a bag of potato chips, you might look at the bottom. I don't know, making some of these things, eye becomes like the data, like where your eye wanders with these online images. You can actually test structures with or without the brand. Like if you just want to understand, great work with some industrial design partners at Target right now to say like, what kind of bottles should be in this category and which ones aren't. Like there's no brand right now. We're just saying, what are these shapes and feels mean to you when you think about this product? And then you can bring the brand in to understand that. And then you get to the final functional package. You want to take it home to make sure people can, they understand it. It's performing well. You really made sure you thought about how it's being used. I know when I was at General Mills, one of the engineers on my, he led the project to get out of a composite can, like, like a Pringles can, or sometimes nuts are in that. Well, Parmesan cheese used to be in that years and years ago, and now it's all in a clear polyester rigid bottle. And we were moving forward, and we did some of this in-home work. Actually, before we started the packaging work, we just asked questions, and I had no idea that a lot of people put their Parmesan cheese in the freezer. I didn't put it in the freezer, but I was in the minority. And so you really want to make sure you understand this whole experience of the package. And you can get that testing. Like for that project, we could ask those questions even before we started designing, and then we would send some packages at home to make sure they work. And then we talked about this whole, it all comes together where you pay for it. You can always ask if people want to pay for it, and they might always say yes, but the real place to ask if someone's going to pay for it is to have them pay for it at the store. So I'm always a little cautious about people saying, yeah, I'll pay a dime more for that. I think in the early testing, I think that just shows they're interested in it, but you can't really go to the bank with that dime. You've got to get that in the store and see where they actually pay that money. So that kind of question tends to wait until you're actually in a real situation and you're tracking sales. So pulling this all together, think of your testing should be iterative, not a single moment. Like you really want to test all along the way, as you could hear. Sometimes your budgets and timing limit this. You think it's a one-time thing, and that mentality really isn't the right thing. The iteration is the beauty in the testing, but you can be super creative with small groups of employees or team members to inform your development. And you really want to advocate for that quantitative testing when you're placing those big business bets and involve a lot of investments. And there's a lot of people on the outside, like we do a lot of testing. We did a lot of General Mills and a lot of Kraft. Most of the time you had an internal testing team that would go secure an outside party to actually conduct the testing, and they would know the right ones for the right types of testing. Okay, we're almost done. We're going to talk about end of life. And so we're going to talk about what is sustainable packaging. There really is no broad definition. I can't point you in a direction like I did at the beginning and say, here's a definition of packaging. It's more how you think about this, and it's evolving and it's tricky, and a lot of balance comes into place. And what I would say is just think big picture and make sure you're not doing one little thing that might be great for one piece of your supply chain, but you really kind of caused a lot of frustration and friction points in another part. So think about how you're sourcing your package, how you're in it, what can the consumer do when they're done with it? And you think of the total experience of offering, not just the package. The more you can back up and look at the total experience, the better you'll inform sustainable packaging decisions. And really don't think about doing those in a vacuum. So this is, internet's unstable again, I'm assuming it's good, okay. This is what I do use as a good definition of the Sustainable Packaging Coalition's definition of sustainable packaging. And it's that holistic view about how are you sourcing your packaging? Like, are you pulling oil out of the ground? Are you cutting trees down? And are you doing that in a responsible way? How are you manufacturing your packaging? Are you creating a lot of waste? Are you not, adding bad chemicals? You don't want to do that. Are you distributing in a good way so you're getting efficient distribution? How you size everything, so the more packages you can get in the truck, the better. Is the consumer, and then how it sits on the shelf with the retailer, and then how the consumer uses it. Is that a good experience? And if they know what to do when they're done with it, so they can recycle it, it can be collected, sorted, and then put back into the system again. So in a perfect world, everything would be circular. And I'm not sure if any of you have heard this, but circular design or circular economies, this is a very much up and coming energy space. And so how do you design things that are renewable, get them collected so they can be renewed? And today we kind of have this linear approach, which in a critical way, they call it take, make, and waste, right? You pull oil out of the ground, you make a potato chip bag and you throw it away. Like, how do we change the thinking there so this can be more circular? That involves a lot of change in the package formats, the systems, delivery, consumer behavior. So there's a lot of energy in this space. And so we focused on packaging because we don't want that food waste that we talked about. It's typically a small portion of the environmental footprint. Now, if I took a bottle of water, that wouldn't be true because that polyester rigid bottle probably has a notable part of that impact to the environment than the water. But if I took a steak, the packaging is a very small part of the impact of that total product because they're thinking of growing that cow and feeding it and transporting it, et cetera. And consumers think this is super important. If you talk to anybody that wants to live a more sustainable life, they will talk about packaging, how they want to recycle, how it's confusing to recycle. And so we want to show up with packaging in a way to show these people we care and that show them that packaging is doing good things, but it can always be better and we can use less of it and come up with better ways to deliver products that may not even need a package, but it creates that circular flow. And so when you talk about an environmental footprint, this is typically called a life cycle analysis, or LCA, and it's a technique to assess all the environmental impacts associated with the stages of a product's life, from raw material extraction, so say pulling oil out of the ground, processing it into plastic, making a pouch, filling it with the cherries, getting it to the consumer, using it, repairing and maintenance, and disposable and recycling. There's not a lot of repair and maintenance in the packaging world, but maybe in the future there might be. But the big thing here is that LCAs or LCA thinking invites that broad look at the entire supply chain. And I can say that when I first came to Target, I was at a conference and this carton company came to me, oh, we want to sell cartons to you because we use wind power to make our cartons. And I was way early in my sustainability journey. And I said, oh, that's a great idea because we have these organic cookies and that would be a nice fit to say they're made by wind power. So I came back from the conference, talked to people at Target, they go, oh, let's do that. And we did all this stuff. And I never, ever looked at the total supply chain. Huge learning on my part. I realized that these cookies were made on the West Coast and this carton company that had wind power was on the East Coast. So now I thought I made a great decision to use these wind power cartons, but really I was having cartons shipped from the East Coast to the West Coast, which totally obliterates any positivity with the wind power because you don't need to ship cartons that far. So that's always been my story to tell people, back up and understand, like, what is your idea and how is it going to impact your current supply chain with eyes wide open before you execute. Needless to say, those cookies and those cartons are not on the shelf anymore at Target. And we talked about this. We're typically, as a package, very small part, but not on all products. When you think about a Coke bottle or a water bottle, it's not. But most food, because of all the energy that goes into making the food and harvesting it and processing it and moving it, it's a much bigger impact on the environment. So you want the package to protect it and not have that waste. Consumers think this is super important though. 78% of consumers, the top two words for 78% of consumers are a package was recyclable and recycled. 57% of consumers think that having an easily recyclable package is important to them. 33% of consumers, at the highest satisfaction of the packages in the store is 65% in the 33. So at the time of disposal, the satisfaction with the packaging goes from 65 to 33. And two of the top three global issues consumers care about are about reducing waste and ensuring environmental sustainability. And they know that their recycling is a key part of that because they can do it at home, they see it, and if they're not doing it, they feel they could do better. So we think about this as a packaging person. You go back and we talked about like product requirements, equipment, marketing, et cetera. You kind of take that same approach here for sustainability. You want to think about your sustainable sourcing, design, and end of life. So where does this package come from? Is it coming from, say you're doing a paper carton, you want to make sure that you're using a lot of recycled content and any kind of virgin material you're using is in responsibly managed forests where they're planting trees, where they're taking down trees, but they have a viable business model where they're not just taking some trees away and then moving on to somewhere else and taking those trees away. There's a lot of certifications out there that can tell you in the fiber world that yes, you're doing this. So you want it to be responsibly sourced. The biggest way to do that is to make sure you're not using too much and you're using recycled content. And then what you actually have to do that's virgin material for the first time, that you're doing that in a responsible way. And then you design the package to make sure you have just the right amount, but not too much. You don't want to create waste, but you don't want to create damage. And you want to make sure when the consumer opens a box of cookies that they're going to eat them and not waste them, or even at Target, not they open a piece of furniture. You don't want that furniture to be damaged, because that's way more unsustainable to pull a lot of packaging out and then deliver a product that's damaged. So you don't want to do that. So that's a balance. And then we talk about this, what do people do when they're done with it? From a sourcing, you want to have less bad chemicals, you want to use renewable materials and recyclable, and you want the practices of your packaging suppliers to be good. Like they're not creating a lot of waste, they don't have any bad chemicals, they're taking care of their workers, they're constantly moving this forward. And you think about how to look at this, you think, how do they use their water? Are they wasting water? Are they reusing it? How much carbon are they emitting? How much waste? What are the, when you think about sustainable raw materials and chemicals, like what are the good actors here versus the bad actors? And then this design, I kind of talked about it, got ahead of myself. But basically, if you look at this chart, if you're on the vertical axis is negative environmental impact, and then the horizontal is the package weight. So a negative environmental impact can be damaged goods because you have not enough packaging, or you have waste. So you can actually have negative environmental impact by not protecting your products, or you have too much packaging, which creates waste. And then the increase of the packaging material here, you want to make sure you're not over packaging or under packaging it for the same reason. And so this is a design decision where there's this balance, and understanding your whole supply chain is super critical, that you're making these design decisions. And you go through all those same business expectations that we talked about. And then we can talk about end of life. So if you look at anything in this space online, there's a hierarchy where the most preferred thing is to reuse something, and the least preferred thing is to put it into a landfill. If you can't reuse it, the next best thing is to recycle it. If you can't recycle it, you can actually burn waste to create energy. The worst thing after that is just to burn it to manage waste. And then the worst thing again is to put it in landfill. And so people have varying opinions, but you really want to strive to move up this list to the top. So this is a picture of a material recovery facility, or a MRF, MRF. And so when you recycle your packaging, this is what happens to it. It goes down several belts. There is equipment involved, but there's a lot of people that are pulling things off that shouldn't be there, like plastic bags. Like I've been to several of these. I've seen pots and pans. I've seen hoses. They can tell you every time of year, like right after Christmas, there's a ton of Christmas lights. People think it's sort of a magic thing. They put it in the recycle bin and everything will be better. They don't feel guilty. They put it in the garbage, they put it in the recycle. A lot of that stuff is really a negative impact because it contaminates the whole recycling stream, which then reduces the value of the really good recyclables, which then reduces the amount of money these facilities get when they sell it and makes it more challenging. So every MRF, material recovery facility I've been in, has a combination of a lot of people and a lot of equipment, and they're literally pulling things off. So as you think about your recycling, if you don't know, we always say, when in doubt, throw it out. It's much better to throw something away than to just think it'll be wish cycled, because a lot of times it'll just get into this kind of situation and you're actually doing more harm than good. So some of the key industry activities in this area are continue to work reducing food waste. Packaging is one lever. We talked about recycling. People are so passionate to recycle, but it's very confusing to them. They might move to a different town, or might be they could recycle a certain way at work, but not at home. There's over 20,000 communities in this country that own their own recycling situation. And so it's very confusing. They all communicate in different ways. They all communicate different things that are recyclable. So it's an industry issue that a lot of people have identified and want to work on it. And then there's industry dynamics to be profitable. Like as the price of oil goes down, those virgin plastics goes down, and it makes it a lot of pressure recycled plastics that you want to use because they cost more. And then there's new chemistry or new recycling coming on. So almost everywhere today in the US, it's all mechanical recycling. You put things in your bin, it gets picked up by your waste hauler, they sort it like at that MRF, and then they mechanically sort this stuff. Like they'll melt the glass, they'll take down the aluminum and melt it down, they'll melt the plastics down to become its same thing again. And hopefully a lot of that will be recycled, but a lot of times it gets lost in the translation. Chemical recycling is something up and coming where you can take a lot of different plastics, kind of just put it into this big old machine with a lot of heat and pressure. It melts it down to the polymers. So you actually can get recycled polymers, but have the performance characteristics of brand new polymers because you're actually breaking the chemicals down. There's different ways you can do it. And this has got two schools of thought on it. I'm super excited about it because I think it allows us to take a lot of the stuff today that's not recyclable and get recycled. And companies like ExxonMobil and Dow Chemical, they're investing a lot in this space, and they're taking some of their internal capabilities to understand how can they chemically recycle some of these plastics. But it's nascent in its status in the US today. And then there's compostable packaging. It keeps emerging. It's getting better and better in the US. You have to be careful where you are to make sure if something's compostable or not. The composters love food packaging because they really want the food for the nutrition to make their compost outputs and their soil and things like that. They don't want just the compostable packaging because it doesn't give them any nutrients. So the best place to think about how to have compostable packaging isn't food packaging because it'll come with the food. So here's something just to pause. I'm getting close to the end here, and I know my throat's getting sore, and you must be getting tired of me talking. But this is something from the Ellen MacArthur Foundation. They have a project called the New Plastics Economy. So if you start on the left there on that light blue box, this is 98% of virgin feedstock. So say you have 100 pounds of plastic, 98% of that is brand new plastic that you made from drilling oil out of the ground. You made 78 million tons of that. 32% of that 78 million tons goes leakage. It gets into the ocean, it's littered, it comes off the top of a truck. It's not managed in a developing country because they don't have the right waste systems. 40% of that plastic, and this is all plastic, goes to a landfill. And some of this could be recycled, it's just not. 14% is incinerated in energy recovery. So now we only have 14% less. So of that 78 million tons, there's only 14% that was collected to be recycled. So the things you put in your bin is in that 14%. 4% gets lost in processing because just of efficiencies. 8% is called cascaded recycling. Some people can say this is downcycling. Some people call it upcycling, but you're not making the same thing. So you might make a plastic park bench or a piece of lumber for a decking, but you're not putting it back into, say, a plastic bottle. Only 2% of that 78 million tons comes all the way back to start over again. So we talk about recycling. It's got to work a lot better than it is today, and this is global, and it's part of the solution. We need to come up with better ways to put less plastic out there, and then what we put out there, we need to do a much better job to avoid it being leaked to nature or going into a landfill. So there's a lot of work going on in industry. Target's part of this project, as a lot of other companies are, to really understand how do we rethink our relationship with plastics. And so because of what I just showed you, by 2050, there'll be more plastic in the ocean than fish by weight because of how much plastic is going into the ocean because the waste is not being managed. And it's going to become more and more of our oil demand and more of emitting carbon into the atmosphere, which we do not want. So I'm going to close it up now, and then I have just a couple of trends. We talked about the raw material suppliers, pull the oil out or melt the sand, and then they make the glass bottles like the converters, and then the manufacturers and the brand owner packages and buy those finished goods and sell them. The consumer uses that package, and then we think about the waste haulers and the recyclers as consumers try to recycle. So a few extra slides here just on some. We talked about sustainability, we talked about e-commerce, some evolution, we talked about that a bit, as things delivered, there's the first mile to get it stamped, then there's those middle miles that get it to wherever it needs to be. The mile that's changing the most is that last mile, how it gets delivered to your house. If it gets delivered by Amazon or FedEx or shipped, or you went to the set up a all new space. And then you have this whole idea of the Internet of Things, given your phones and the way we're connected, how you can connect to anything to like learn more about your product or understand when it's time to order more, because your package becomes something that you could scan or read in an interesting way, like a QR code. It becomes a connection moment. And then there's a lot of customization of products, things made only just for you. You have to think about safety through all this, right? Like safety of your product, safety of your personal information, because you're taking a whole different approach now in delivering things to the consumer. We talked about this, and I can talk about this all day, as you probably can tell, but basically there's this lot of anti-plastic sentiment amongst consumers, and companies are trying to figure out what to do without making the wrong mistake. It's not always good to go from plastic to glass or plastic to metal or plastic to paper. Plastic's extremely efficient on how you use it. At Target, a plastic bag costs a third of a paper bag, and it takes way more less energy because you're not watering trees and putting that tree through a paper mill with a lot more water and making paper bags. You're actually melting or cracking the oil into big plastic and then melting it to make a bag. So from an environmental perspective, even though you can't recycle a plastic bag, it has much less impact on the environment. So this is a tricky space companies are navigating to embrace this anti-sentiment, but make sure we're doing the right thing. We're really trying to understand how to divert all packaging from a landfill and create a circular economy. We're designing for recycling now. We're not just designing to protect, contain, and communicate. We all want to use more recycled content. How do we look at packaging as an asset, not a waste? So we don't think about this take, make, and waste. We think, how are we designing this so it can come back into use again? And then as you think about packaging for shorter shelf life, people want products, that are fresher. Maybe you don't need to add a lot of those barriers to your package because you don't need to have it last on the shelf for a year. You maybe could come up with a simpler structure that gives you less shelf life, but might have a better way to be recycled. And then obviously anything that gives you less waste is more sustainable. So here's a couple things to think about as we just close. Currently, the US curbside recycling system is successfully capturing 32% of what they could. So we're only getting about 12 million pounds of the type of, this is the weight of the empty packaging. So think of bottles, jars, tubs of yogurt, jars of peanut butter, bottles of water. We're only actually capturing this recycling system a third. The reason we're not capturing that other 2/3 is multifaceted. People don't have access to recycling, multifamily housing, they don't have access to recycling. People confuse and they don't recycle. You might recycle out of your kitchen, but you're not recycling out of the room. Or you might recycle, but your roommate might not recycle. So there's all these headwinds we're trying to understand, and it's easy to have more people enter the space and actually recycle. And there's 20 million tons of curbside recyclables that are disposed of. And so this is, again, just kind of playing this back, but this is the 20 million tons of materials that could be recycled are going to land. We have to just figure out a way to divert this with things that are currently recycled today. Only half of Americans have automatic access to curbside recycling, and some who have it don't participate, and not all who participate. So I kind of mentioned this already. But you have to have equal ease to get a garbage bin to a recycling bin. In another state, you get a garbage bin automatically when you move into a new place, but you have to call and get a recycle bin. And even though that's a small action, it does have big impact because you might forget for a few months or week that you need to call and get that recycle bin and set that up. So one of the things that's really out there is to make sure it's easier to recycle something than to throw something away. So there's a lot of work in this space to help move that forward in a positive way. Many communities are paying more to send these materials to those MRFs because the markets aren't there. And so what's happening now, you've seen this maybe in the news, that a lot of communities are not taking glass to recycle because it's costing them more to recycle. They can't sell the goods. They have to actually pay to have them picked up. And these community budgets are stretched. So there's a lot of headwinds in this space that we're working on, which is getting us more now into policy space and federal and state legislation to set the model up so that the money flows to in the right way and invites the right behavior. So if we talk about e-commerce, we kind of talked about this already, the different retail, multiple shipping. When it comes to food, it's a bit tricky because you have to manage your temp control. So you can order like a new pair of jeans or a book online and you just can send it. But when you think of food, There's a lot more that has to go into insulating that food and delivering it in a way that it gets to you the way you want it. Talked about this already. I think these flexible manufacturing systems, making orders, producing to order versus just producing a bunch of stuff, and you're making more specific things and having shorter shelf lives. Supply chains, if you look at Amazon or Target, and I'm pretty sure Walmart's the same, everything's handled in each. So like a bottle of Tide or a jar of peanut butter is an each. It's not a shipping case. So that jar, that jug of laundry detergent is being handled on its own. So again, the package isn't staying in that corrugated box forever. And so the package has to survive the supply chain in its the package that the consumer sees. Smart technology like QR codes on packaging. There's even marks now that you wouldn't see as a consumer through one of those recycling. It could be scanned and go into a certain path. Information. We talked about this manufacturing where you're going to make to order and then managing food. We talked about the Internet of Things already, basically how to use the package as a way to connect because you can scan it or use your phone in a way. Customization, we talked about this as well. Digital printing is sort of a big thing in the world where you can print things like you've seen the Coke, bottles of Coke with names on them. Different ways where it's much quicker turnaround than the lawn printing run, so you can do things more customized. And we did talk about this one already. So making sure your food is good and then your personal information is managed in these new ways. So pulling this all together, I know I overwhelmed you with a lot of stuff. It's super high level, just to give you thoughts to think about. But at the end of the day, remember, there's a purpose to that package, and it's to deliver a food to a consumer that they want to and can eat in a safe and quality way. So remember that all the way through, because that's the job the package is there to do. Look at your total supply chain from the sourcing to the end of life, so you're making the best decisions you can. And a lot of times you'll be in the gray. It won't always be black and white. You do the best you can with what you have. If you think that life cycle thinking, it helps you back up and look at everything to make sure you understand the consequences of your decision. And it will always be a balance. There'll be some easy decisions, but there'll be other ones that just best call you can. And so I'll end with what I started with. Packaging is best described as a system of preparing goods for transport, distribution, storage, retailing, and use. It is a complex, dynamic, scientific, artistic business function. Packaging functions range from the nature that are the marketing oriented, as we started today, talking about the product to the end when you engage in the consumer. So I want to thank you all very much. I didn't see any questions in the chat. If you have any questions, you can definitely ask me now, or if something comes after the class, you can shoot me an email. Really just want you to appreciate packaging as part of this lecture because it's such a high level time with the packaging, but I think it does give you a sense of how multifaceted it is and some of the things to think about. Working early with your product development and packaging partners, looking at the whole system, and just remembering to understand what can go wrong with your food and what your package needs to do.
I have a question.
Yeah.
I was just wondering what Target does to try to eliminate some of that food waste that is seen like on its shelves or in supply chain.
Yeah, we try to eliminate it, obviously, by trying to move the food through as fast as we can. So we're not, we're not like buying too much and then not selling enough. And then we have a waste minimization team, and they work at the local level to make sure that anything that can be donated, that's got enough time to get somewhere and it can still be safe to eat. So like, cookies and canned and jarred goods are good because they have a lot more like runway to sell them. And then some places we try to do with the produce, which is actually the harder things to sell or to divert and have put into his hand to consume. But it's very regional based on what kind of waste we have. We divert it, but we definitely to divert. So that team is incentivized to find those local solutions so the food can be repurposed and given to someone.
And then one more question. What are some of the newest up and coming types of packaging or stuff that you see in the future that are coming out?
Well, I'm super jazzed by this whole idea of reuse and refill, and like, if you asked me that question, like, I don't even know, 5 years ago, Paige, I'd say, oh, it's never going to come to food. Like, food can't do that because blah, blah, blah. And I think I've changed my whole tune to say, like, how do we deliver goods to humans and not think about it having to be in a package? Is it a refill? Is it a subscription? I think you have to really think this through and like shift your head and kind of, you have like this jarring experience where maybe I don't believe in packaging. I believe in getting products to humans, and how does that help me think differently? So I see there'll always be material innovation because there's always going to be a material innovation. But I think the bigger thing is systems innovation. Like, how do we move? And so like at Target, 5 years ago, I'd say, well, I'm working with my team and my coworkers to reduce this package or get more recycled content. We'll keep doing that. It's foundational work. But now I want to say, let me talk to the store ops team. Let me talk to the merchants. Let me talk to the distribution center and say, like, how can we use returnable totes, or how can we get products in the store that have some sort of a easy to use, very safe way to use refills? So maybe you don't start with food, but you start with detergent, or you start with dog food, where there's like a little lower hurdle. Does that make sense?
Yeah, that was awesome. Thank you.
And if you guys got any great ideas, shoot them my way, because this is an all activity sport. There's so many good ideas out there. And as a big company, we need to be super open to little company ideas to understand how do we help them and give them like access to the shelf at Target, or even learn from them.
I have a
And-
couple questions too.
Yeah.
Oh, sorry.
No, I was going to end it, and I'm always too quick to do that.
So I know in other states they have recycling like refunds for, people who bring in recycling. I mean, obviously we're in Minnesota and we don't have that, but do states that have that program in place see higher turnout for recycling?
Yep. If you
Okay.
incentivized, I can't say it today, incentivized recycling is super effective. So like bottle bills, like I grew up in Michigan, like reverse vending machines, and I've been in Target stores around the country where they have to offer that, right? And people do that. The other way is like pay as you throw. So some states have like say you get one small bag to throw your garbage away. If you need two, you have to pay more. That's what I was saying earlier, Catherine, about getting into policy. The economics aren't helping us right now. We need policy. And so a lot of the NGOs that Target's members of and our government affairs team are watching this space. And there has been some federal legislation put forward. And I think the cool thing is it's sort of a bipartisan space to be in. So most people want to recycle, most people want new jobs. So I think there could be a chance to get some runway here and actually have some ways there's many funding mechanisms. One of the simplest ones called extended producer responsibility. We as Target would a part of a penny for every pack, and the more recyclable it is, the less we pay. But like a pouch of those dried cherries, we pay more, recycle it. All that money, this is where the government affairs team's freaking out because all that has to be tracked. Like how many pouches did we sell? And if we sold General Mills cereal, like how do everyone get what they sold? You get a bill at the end of the month or end of the year, you write these nice checks, they go back to the communities. And how is that money being managed so it does drive system change, doesn't just get back to a committee and they decide to like their road. So a lot of work in that space. Incentivizing is a huge trigger.
Okay. Yeah. The other question I had was about, you were talking about how packaging can drive consumers to purchase a material, and you were talking about the first like look at it, and then the sorry.
The first moment.
Yeah, and then the second
Moment of truth. Yeah.
Yeah. So how do you tell the difference between those, or like how can you find those like values that make sense?
You can test for them. Like you can actually do a test and have somebody walk down the aisle and see if they noticed it. And then you can do the actual, like we could just go into a Target and say, we're going to do this. And you and I are just standing in the next aisle watching people. And we've done this. You don't do it around the holidays, but you can do it when it's a little quieter. Or you actually put it out there and you watch your trial and repeat. So if your trial's high and your repeat's high, that means you had a good first moment of truth and a second moment of truth.
But
And
how
so
how can you tell if something's the first moment and how the second?
Well, you can actually test it. Like you could put something on the shelf, and if people are noticing and picking it up, you'd say, okay, we're there, and then you could confirm it in actual market testing. And then your second moment of truth, really, you could prove it because you could have an in-home test where you take the pouch or the bottle or something home and the consumer's happy with it, and then you confirm that, like when you watch your sales. So
Okay.
you can get like early indicators. One interesting story, we ran when I was at General Mills, this is so old, and I don't even know if you guys know what this is, but Bisquick is this like baking mix, right? I mean, you can make a lot of things with it, but biscuits is one. And it was in a yellow box with an inside liner that didn't close very well. And there was a 40 ounce, a 20, a 40, and a 60 ounce. And the engineer that was working on this, she had this great idea. We should put it in a stand-up pouch with a zipper because it's definitely a multi-use and they could scoop it out and close it. So she did this great project in this beautiful pouch. And when she did it, we put it in a test. And so we had the 20 ounce in a carton, the 40 ounce in this beautiful shiny yellow pouch, and then the 60 ounce was in a carton. And the sales for the 40 went down and the sales for the 20 and the 60 went up. And that was one of the moments we had this epiphany, like people are looking for shape and color. They're looking for a yellow box. They don't see it, so so then we had to go back and put all three into the pouch to show that people liked it. But it was such a learning to say they loved it, but they weren't looking for a pouch, right? They were going down the aisle, and if they didn't see that little square yellow thing, they reached around this incredible package.
Huh. Yeah, that's interesting. Thank you.
Ooh. Thank you. And again, I thank you all for your time. I wish you super success in your careers, and you got my email if you have any questions or comments, or I can network with other folks if you want to explore packaging. And thank you, Dr. Kumar, for another chance.
Thank you, Kim.
Yeah.
Wonderful lecture as usual. Pretty thought-provoking and very helpful to the
I kind of
students.
zip through the technical stuff and then I go deeper
I
into
know.
sustainability. Give me feedback one time and say, you need to go back the other way.
That's true. Yeah,
All
a lot of
right.
people are saying thanks. Yeah, thank you.
Yeah, bye.
Bye. We'll be in touch. Yeah.
Okay, bye-bye.